welcome. Thanks ever so much for coming. I'm going to keep this talk very, very short because actually you really don't want to listen to me. You want to listen to this great lineup of speakers we have tonight, David, Adelina, and Derek. And hopefully during the course of the evening, we'll learn about what NATS is and why we think it's so important in the future of distributed applications. I'm Stuart Harris. I'm, as Victor said, one of the founders of Red Badger for My Sins. And I have to obligatorily start with talking a little bit about Red Badger and what we do. So we're a consultancy based in London that is obsessed, I think, with helping large organizations transform their digital product capability. And that is all about digital products, about platforms, and about capabilities. And when I say capabilities, I mean embedding knowledge and skills into an organization so that actually the organization doesn't need us. But it's in our blood. Distributed applications are what we do. And platforms are massively important. And I selfishly want to talk about how NATS is going to be a key enabler in next generation platforms in my talk, but I'm only going to spend 10 minutes on it, so your eyes hopefully won't glaze over. These are some of our clients. And as you can see, there's quite a few financial organizations, banks and fintechs on there. And there's even more at the moment that we're working with. And we believe that that NATS can be a key enabler in helping financial organizations, especially, but really every large organization to move to the next generation platform, which I'll talk about more about in a second. So we love NATS. I just stole this strapline from nats.io because I think it's actually quite good. Connective technology, or connective tissue almost, for adaptive edge and distributed systems. And that, I think, is the key thing. It's the connections that we can make really easily using NATS between services wherever they are on the planet. So I don't want to spend a lot of time talking about what NATS is, because over the course of the evening, you're definitely going to know. You won't go away without knowing what NATS is. But from and it's so many things actually, all packed into a tiny little binary, which is only 15 meg big. And that's actually quite key to success, I think, is in that there's a lot crammed into a tiny little thing. So it's cloud native because it's so easy to run it in a container on Kubernetes. And NATS binaries, instances of NATS, connect together, self-forming, self-healing, cluster, a mesh effectively of messaging substrate, on top of which we can build distributed applications. And that, for me, is the key thing. You know, we've had lots of message brokers in the past and PubSub and all that sort of stuff. That's kind of, you know, great, especially when you can do it at the speed and the performance that NATS has. But I think this is so much more, because it's all about connecting the mesh, the substrate, almost like a dial tone, on top of which you can build distributed applications. And I just want to explore very briefly what that means for next generation platform. But before I do, I want to talk a little bit about walled gardens. In 1995, I was seduced by Microsoft products and services and the whole Microsoft ecosystem. And I entered a Microsoft walled garden in 1995, and I didn't come out of that walled garden until 2010. And that's 15 years of my life that I lost, and I'm not bitter about it. But I think, and Microsoft was a very different company then than it is now. I mean, they do great things. So this isn't I'm not slagging Microsoft off. But the concept of a walled garden is really interesting to me, having spent so long in one. Because inside the garden, you get an answer to everything. You've got an answer to every question you can possibly have. Might not be the best answer in the world, but it's good enough. And it feels like a cozy place, and it looks great. And it's easy to be seduced and just think, oh, I'm happy here and I don't need to go anywhere else. And it's not until you kind of look over the wall and see what's going on outside the garden that you actually understand that actually maybe this garden isn't the best, you know, I don't want to spend the rest of my life in this garden. And I want to, in the concept, you know, relate that to cloud vendor lock-in. I'm going to come back to NATS, don't worry, but and actually talk about how that can save us from this. But it seems like the last decade has been characterized by like a rush to the cloud. We've all rushed into a cloud provider. We've chosen a cloud provider and we've moved into that cloud provider. And if you're a reasonably large organization, you might have multiple cloud providers, you know, especially if you've grown by acquisition. You may, you know, part of the organization may be in AWS, part in Azure, part in GCP, etc. A bank that we were working with recently had Azure in one country, GCP in another, AWS in another, and they like came to us and said, like, how do we build a distributed application across all of these cloud providers? Like, we don't want to build it in one. We want the services to be close to the user. We want to build a single distributed application across all of them. And we spent a lot of time thinking about what that meant. And we concluded that actually what you've got to do is lift yourself above the cloud, or above the cloud providers, and actually push the cloud provider down a little bit, actually, so that the cloud provider then just becomes a supplier of compute and storage. And if you can do that, then you can build your applications above all the clouds, and actually services don't even know which cloud they're running in, and they can run anywhere and they can move around. And if a cloud provider goes down, the whole cloud provider goes down, doesn't matter, because you know your application is distributed across all of them. So Ayush, who is in the audience and who's going to go red, and I did a talk at KubeCon in Los Angeles last year about where we demoed this happening, where we actually had services running in GCP and AWS, although they didn't know which that they were running in those cloud providers. And we took one down and demonstrated seamless recovery, seamless failover and recovery, basically, which is quite something to be able to build applications that don't even know what cloud provider they're in. So, and there's a link to that I'll send in later on in there. So we want to be multi-cloud. If you're a financial organization or you're in a regulated environment, the regulator will probably want you to have a like back out plan. Like yes, you can go into the cloud, but how do you get out of it? What is your plan for if that cloud provider goes down? And actually the financial regulators in the UK have got quite vocal about this recently, because you could imagine in the old days when every bank had their own data center, it's unlikely that all of them would go down at once, right? But now that they're all in AWS and AWS goes down, we don't have a banking system in the UK. So it's quite an important thing that there is a strategy that spreads the risk over multi-cloud providers. But I don't like to think of it as multi-cloud. I like to think of it more as cloud agnostic. So that, I think, is a subtle difference, because it's not really about building applications that are lodged into every single cloud provider or multiple cloud providers. It's about building applications that don't care or don't know that they're running in a specific cloud provider. And you know, every single service that we use, the cloud providers want to keep us locked in. They really want to, and every service that we use keeps us further locked in. So this is what we really want, you know, more than multi-cloud. We want like hybrid. We want to connect edge, IoT, on-prem, all the clouds together in one homogeneous substrate on top of which we can build our applications. And that's the promise of NATS. WASM Cloud is a good example, which I'm introducing briefly here. And we talked about this at length at the last event, and our friends at Cosmonic did a really good talk and demonstration about how WASM Cloud can enable exactly the scenario that I've been talking about. But this leverages WebAssembly for hosting the core business logic. adds capabilities which run on the platform, and then puts underneath that NATS. And it puts NATS underneath it as a substrate on top of which all this runs. And that allows those services to run absolutely anywhere, at near edge, far edge, IoT, industrial IoT, on-premise, even in a web browser page. You can run a node of the cluster with services running on it in a web browser tab, which is like a level of abstraction because you've got WASM Cloud. So you've got WebAssembly inside WebAssembly, which is cool. But it works and it's great. We've written a paper about this topic, about how, so when I say we, in conjunction with Derek, who is here, who's going to talk at the end. He's CEO of Synadia, which is the company behind NATS. And I can't wait, because I've been listening to him all afternoon, and it's absolutely amazing to listen to. And Liam Randall, who's the CEO of Cosmonic, who is the company behind WASM Cloud. WASM Cloud is a great example of how all these technologies come together to demonstrate what next generation platform looks like. So we've written a white paper, download it. If you want to scan that now, you can. But if you don't worry, because we're going to ram it down your throats anyways. We want to basically connect everything, wherever it is on the planet, be location agnostic, location independent, location unaware. I mean, I don't know what words you want to use. Geographically distributed, doesn't matter where it is, it can run there. And one of the enabling technologies, which is also from Synadia, is NGS, which is a NATS global supercluster that you can join to from anywhere on the planet. And we actually used this in the demo that I was talking about that we did with Ayush last year at KubeCon, because you can create a leaf node, a NATS leaf node, and just join it to NGS. And then you're effectively plugging yourself into a global distributed network of messaging substrate, which you can build your applications on top of. It's really powerful and great fun. I mean, really is great fun to play with. So tonight, hopefully by the time we go home, we've got David and Adelina and Derek going to teach us all, talk to us all about why NATS is important in different categories. But I just wanted to touch on what's important, what I get out of it really, which is about being the foundational layer in next generation distributed applications.
Okay. So hello, I'm Adelina Simeon, and I'm a technology evangelist at Form3. And today I'm here to tell you about NATS, because that's the theme for tonight. So it's the NATS extravaganza. I've been at Form3 since September 2021, and I'm a Gopher since 2018. So everything I do is kind of like Gopher filled. And for the people here today in person, I've brought some stickers which you can take from there. For everyone virtually, you can download all the Gophers you want. So you have Gophers as a service. So Form3 work with some really great customers, which you can see. And we started in 2016, and our name is derived from third generation cloud computing. And we run a cloud native payments platform. We have about 260 employees, of which about 130 are engineers. And we're 100% remote. So yeah, that's just a quick introduction to me and Form3. So since I'm one of the first speakers, I'm first going to introduce Form3 architecture, which is going to be the starting point before we integrated NATS. Then I'm going to run you through some NATS fundamentals and JetStream, just so everybody is introduced to all of the concepts for everyone else. And then we're gonna wrap up with how we use Form3, how we use NATS at Form3. And I'm going to show you kind of like what's next for us. Okay. So Form3 exposes a single API endpoint for our customers, which are financial institutions. You saw them on the other slide. And then they integrate with our API, and we then pass on financial transactions to external payment services. And these external payment services that you see here, these are the schemes that are most popular in the UK and in the EU. And then the external payment schemes actually do the transactions for the transaction of the money transfer. So we're talking about the financial transactions that are fundamental to the way we live our lives. You're talking about, you know, paying your rent, sending money to your friends. So the way that our payment service architecture looked like was what you see here. Our payment services would receive the payment, and then we would fan out the transaction in the internal model that we mapped. We will fan it out to our gateway, validation and gateway services. And these services were in charge of securing our payments and then actually passing it on to the correct external payments infrastructure. And what you see here is that we also have FPS services for in 2 data centers where we've built our own private cloud from the ground up. And the reason we did that is because of regulatory constraints when it came to actually running FPS transactions, which couldn't be done in the cloud. So another way that we can kind of look at our platform is the technologies that we started out with. So we have our payment services, which are written in Go, and that's why I put the little like precarious gophers there. And the payment services are hosted in EKS. And then we used, as I showed you before, SQS and SNS for message fan out. And finally, the data was saved in Postgres running on RDS. And then the connectivity between our cloud and the data centers was done with Direct Connect. Okay, so that architecture has some pros, but it also has some cons. And it was really easy. It was a really good place for us to get started. It's easy to add new schemes. It's easy to secure and scale. But we did run into like some teething problems when it came to the actually scaling past a certain point. And we noticed that there was some spikes in transaction latency of up to 300 milliseconds. And we seem to be outgrowing this architecture that we had put in place. There's also that pesky vendor lock-in that Stuart was talking about earlier. And also the SQS and SNS set the limit of our SLA, which is really important for something like payment services to have a good availability, like an off the charts availability. Okay, so we decided that we needed an event bus that would allow us to maintain our SLAs and also give us lots of room to scale. And NATS is designed for speed, and it was, as we heard also from Stuart, it's got really small binaries. So it was a really good fit for running in our data centers. And one of the cool things, us as a Go house, one of the cool things was also the fact that it is open source and written in Go, which was a huge plus for us because, you know, we are able to integrate it easier and like have a look at and actually see how it works. So we immediately identified NATS and decided that the SQS and SNS fan out was a good fit for the pattern for replacement. Okay, so this is I've now kind of introduced you to Form3 architecture and where NATS might fit in. I'm going to give you a really quick run through about some NATS fundamentals and JetStream, just so everybody's on the same page, but I won't go too in depth with it. Okay, so core NATS is a fire and forget at most once messaging system. I love the term fire and forget. So NATS does its best to stay available, but if your subscriber is out for the count, then it's not going to receive the messages. So there's no queue groups and request reply. And I'm going to give you a quick run through. I'm going to give you a quick run through of each of them. Okay, so pub sub, we can kind of like, we can equate it to the SNS fan out. What happens is that messages are organized in subjects, and then you subscribe either with the name of a subject or with some wildcards, which I'll show you a little bit later. And what happens is the publisher publishes stuff on a subject, and then everybody who's subscribed to it receives all the messages. So this is very useful for message fan out, like I said. Then you also have queue groups, and subscribers register to a queue name. And unlike the fan out, in queue groups, NATS chooses one subscriber at random to receive the message. This is a great fit for scaling up an application. So like, let's say I scale up a whole bunch of services, and then NATS makes the balancing between all of them. And then once you're done with the volume, you scale back down, and you don't have to do anything else. And another cool thing is that queues are not configured on the server, but they're configured on the subscriber side. So that's, again, a lot of flexibility. And the subscribers in a queue group can also register different topics. And what you see here is that the first two publishers they match the subject. So that's where they get their messages, but the third one doesn't, so they don't get the message. And request reply is used to receive and acknowledge. And when you send a message, you include a reply subject, which automatically gets sent back once the message is received. So you don't have to like in code say, hey, I've received the message, and then send another message. That's like done in out of the box. Okay, and there are two wildcards as well. So you've got the partial, which matches one single token, and the full, which you can see here as the greater than, which matches multiple tokens and has to be at the end of the subject. So I've demonstrated here with the pub sub pattern. What happens is subscriber one matches because it does a partial match, one single token for UK. Subscriber 2 uses the full, and it matches because there are uk.new, so that matches with multiples. While subscriber 3 does not match because there are two other things. There are two parts to the subject. So you got uk.new, so that doesn't get matched in the third one. Okay, so NATS core already has like lots of advantages. It's like very, very fast, and it's got low configuration, and it's lightweight, and it's likened to UDP. But unfortunately, there are some drawbacks like the missed messages, and that doesn't really work for payment services such as ours. So to kind of like to address the need for message persistence, NATS streaming was introduced. And what you see here, I've borrowed this diagram from the NATS docs because I think it's great. What you see here is that the streaming module is a sidecar to the NATS server. All of the clients, they talk to the NATS server, not to the streaming module. And then the streaming module and NATS server, they communicate with proto-buffers. So messages can be persisted, and you can replay them so that finally you have the persistence you are looking for. However, as we enter the realm of message persistence, it's time to also look at JetStream. And JetStream is the replacement for NATS streaming, and it has it's the new generation kind of message delivery. And it has at least once delivery, data at rest encryption, and horizontal scalability, which are some great features that all mature production systems need. And personally, I was a little bit confused about the difference between JetStream and NATS streaming. So I included this slide to show just like two different some of the differences between them. So JetStream is horizontally scalable, meaning that like all of the nodes can process messages. That's not the case for NATS streaming, where only the leader can actually process messages, and the replication is only done so you don't lose messages. As we'll see soon, JetStream has push and pull message consumption, while NATS streaming only has push. And streams are regular NATS subjects in JetStream, but in NATS streamings, messages are published to a channel and don't support wildcards, which was one of the really, really popular features of NATS core. Okay, so I'm gonna very quickly tell you about the components of JetStream, and then we'll wrap up with the use case at Form3. So streams define message storage and retention, and they consume normal NAT subjects. And they support a wide array of retention policies, and you can either do a normal unacknowledged publish, or you can add an acknowledged publish. And then you've got your consumers. As I mentioned, they're both pull and push. And there's no dead letter queue built into consumers, but you have a maximum delivery attempt. You can have durable consumers, which will continue consuming after reconnect, or you can have ephemeral consumers, which won't do that out of the box, but you can still use kind of like a time or an offset from which to consume. Okay, so that was like a very quick run through of NATS. So I hope that was useful for those that haven't used NATS before. And now I'm going to tell you more about NATS at Form3. So we immediately identified, as I told you, the fan out pattern as a good use case for NATS JetStream. And we also use the first migration that we did was in the data centers, which there are 2 data centers, and they use the NATS streaming to send messages to each other. And we've been using NATS successfully in production, delivering over 1 million messages a day in just the data centers. And this has given us some really great results, and it's helped us reduce those spikes in SLAs that we were talking about before. Another cool feature that we are using is message deduplication. So you can configure JetStream to deduplicate messages in a window. And this helps us remove duplicates directly on JetStream instead of performing checks and saving us message delivery. Then, of course, there's the clustering. As I said, the horizontal scalability is built in. And the NATS documentation says to have about between 3 to 5 servers so that they can form a quorum, and you can ensure the best data consistency and failure recovery. Okay, so the verdict is that NATS has helped us a lot move to cloud agnostic technologies, and it unlocks our ability to migrate our platform away from the vendor lock-in that I was talking to you about before. And what I showed you before was kind of like a stepping stone of the architecture that we wish to go to, which is exactly the cloud agnostic architecture that Stuart was talking about earlier. So what we see here is that we don't want to care about which cloud we're running in anymore. Like, the cloud can be anything. And then we can host our payment services in the managed Kubernetes of that cloud. And then we can use NATS as the messaging platform that glues everything together. And that's really great, because that's kind of like what NATS was designed for. And it works kind of already by design. And then we use CockroachDB as our data layer as well. And when it comes to connectivity, we can use the managed cloud to on-prem connect service. So yeah, one last thought, because I asked our head of platform and our head of architecture until I was blue in the face, why didn't we use Kafka? And the answer is that NATS is just so much more lightweight. There's no JVM, and it was so much easier to configure as well. And we know that it can handle great loads because lots of really large platforms are powered by NATS. Okay, so I've also put together a Go demo, which you can have a play around at this on GitHub here. And I'm going to upload these slides there as well. So you can have a play with, I've put together some subscribers and some publishers that you can try to have a look at. And thank you very much for listening. You can check out our podcast on the pod on episode 5. Derek is talking, and he tells a little bit about the story of NATS and the design decisions. So that's a little bit more impressive if he's not standing in the room, but just give it a listen anyways. Solid episode. And you can chat to us on Twitter as well. So thank you very much for listening.
Thank you. So I'm Dave Ramsbottom. I work for a company called Fleetcore. You probably haven't heard of us. Nobody has, but we'll get onto that in a minute. And I'm an architect. So I'm the head of architecture for Fleetcore in our international fuels business, which is basically everything outside of the US and South America. So we're headquartered in Atlanta, but I look after the architecture. So I'm an architect, so I'm going to kind of raise it up a little bit. NATS is one part of our ecosystem. So I'm going to kind of talk you through where we are in Fleetcore, what we're doing as part of transforming our services, and where NATS fits in and why we've chosen NATS as a key component. So I'll just take you through who we are. Most people haven't heard of us. I'll talk you through what we're doing with our transformation of our business, and you'll see why we need to transform, and I'll tell you who we are and how we've got to where we are. And I'm going to do a little bit of a deep dive into what does that transformation mean in one particular aspect, and then why we've chosen NATS, and then what are we going to do going forward, because we're very much at the first stages of our journey. So Fleetcore, we're a global company headquartered in Atlanta in the US. We're just over 20 years old. Revenue is, what is it going to be? 3.2 billion this year. And we've largely grown through acquisition. If you look bottom right, it says since we IPO'd, we've done, it says 45 out of our 98 deals. I know we've actually gone over 100 deals. We tend to do, 2 or 3 largish deals a year through acquisition. And when you do that as an organization and you're trying to grow at 10% a year, you end up with a very fragmented landscape. We acquire businesses, and usually the technology due diligence comes at the end, and it's kind of, is there a really, really good reason why we shouldn't buy them? Usually, no, it's okay. And so we acquire the business. So we are multi-cloud. We have got every technology that you can think of. If somebody says, do you run this technology? The answer is probably yes somewhere. I've been with Fleetcore for 3 years. I don't know everything that we've got running everywhere. We've got, 90 odd businesses that we've bought. And what we've done when we've kind of brought them into the fold is we've, as you would expect, onto a common platform. So we've got lots of siloed stacks of businesses that run their own tech stack with some common stuff at the bottom, but largely it's a fragmented pillar of technologies that support each of the businesses. If you're in the UK, you might have heard of Fleetcore, but you might have heard of All-Star if you've had a fuel card. If you've ever been to a filling station and you see the symbol that says, these cards accepted here, you'll have seen MasterCard and Visa. But if you have a look next time you go, you'll see All-Star and Key Fuels will definitely be there. We also have fleet businesses that look after the buying and maintenance of fleets. Epics with their OneLink system, and R2, Epics is the kind of the car fleet management system, and R2C, if you know anybody in the commercial business, will probably use them. So we're a B2B company, okay? We enable payments between our customers and merchants. And our growth mainly came out of the fuel card business, where we've got pretty much every filling station in the country, certainly in the UK and Europe, that our cards are accepted at. So it gives our customers an advantage because you can get discounts, and we can negotiate discounts with merchants. And also we can put buying limits on what you can buy with our cards. Where we've got closed loop cards, where we own the whole cycle, we can manage the products that you want to buy. So we can give our customers that kind of confidence that you're not going to go buying alcohol with your All-Star fuel card. You can only buy petrol. Now, I wouldn't recommend drinking petrol. So our core system transformation, we are transforming most parts of our business. We're moving from waterfall to agile. We're transforming our mobile application. We had, I don't know what it is, something like 35 different mobile applications from all the different businesses, most of them not rated very highly. We're on a program of transforming that, and the new version gets kind of 4 stars out of 5 on the App Store. we're doing our website, we're modernizing that so we can have one website stack that will support all of our businesses that can be white labeled. And we're exposing our services through APIs to our partners and our customers so that you can integrate with us directly. So that's the kind of the front end system. The back end, there's loads of stuff at the back end in terms of transforming how we do finance, our analytics and reporting, and driving the business through data. But the bit that I'm going to talk about today is the kind of the core system in the middle. The bit that manages, at the moment, just our fuel card systems is what I'm going to talk about. But you'll see when it comes on to the end, this is just the start of a much wider transformation. So when we're talking about a fuel card system, it's onboarding customers, signing them up, giving them tokens or cards, either a physical piece of plastic or a virtual token that sits in a wallet on your phone. They then go and transact with it. We approve those transactions. The transactions come back into us, and then we bill them. We work out what do we bill the customer and what do we pay the merchant and what's our profit in the middle. So that's largely our business, be it fuel card, be it lodging, whether you're buying hotels, be it paying for flights, or whether you're transacting to pay other businesses and bills through some of the kind of non-fuel businesses that we've been acquiring. So a fuel card system is largely 15 different services. I won't go through them all here. I could bore you for quite a long time on each of those because I talk about this quite a lot in our business. But what we're going to talk about is the approach, which is a strangulation pattern. So what we're going to do is take out one of those particular key pieces of functionality, build it in a scalable, multi-tenanted way, and then migrate the functionality out of the existing system into the new service and then back into the legacy system. And we've got 15 legacy systems, 15 legacy fuel card systems globally that are part of this program. Yeah, we've got multiple global teams. We are a global company. So we've got North American fuels businesses and teams working over there. We've got people in the Netherlands. We've got partners out in India. We've got people in the UK. So we are very distributed. We have lots of teams working independently, and lots of the businesses are trying to develop products and sell them to customers as quickly as they can on their own particular stack. So it's a complicated environment. It's been likened to trying to change the engines on an aircraft while you're flying at 30,000 feet without killing anybody. We've got to keep delivering value to the business. We've got to show them that what we're doing at this transformation is adding value. We've got to make it multi-tenanted, scalable, and reliable and resilient. So I'll just talk you through the bit where we're starting to use NATS is in our pricing service. So broadly, what you do with a transaction when it comes in from a merchant, there's an ingress point where we validate that that is a valid transaction file, that the transactions make sense, and then we tokenize them. So we remove any of the sensitive card details and we tokenize that card data so it doesn't exist in the rest of the system. We then go on and enrich it. So we look at the basic information that comes in and we add our own data into it. What's that customer's ID in our system? What's the merchant's ID? So rather than it being just what comes in on the transaction, we add more data so that we can actually make decisions later. And then we go and do the pricing. We actually work out what we charge everybody and what we pay people. And then from that, it goes on to whatever downstream services are going to need it. So are we going to alert the salesperson that their customers just started pumping? Are we going to send it to the billing and settlement services so we can actually do the financial transactions? Are we going to report on it? Or how are we going to monitor the business and drive what products are making profit for us and where do we make our money? So I'll just dig in a little bit more. The pricing service, it needs to be flexible. So we need to be able to cope with all the products that the 15 different systems currently provide. And they've all grown up and they're all slightly different. So we need to be able to standardize them, but also account for local variations. So it needs to be flexible and we need to be able to incrementally make changes to the service so we can cope with not just the existing systems as we bring them on board in kind of a strangulation pattern, but any new services that go forward. And one of the advantages is that what we want to be able to do is, as we move into EV vehicle charging transactions, so as fleets are starting to buy EVs, we want to be able to build that EV pricing service once and make it available to all of our businesses. So I'll just talk you through as an architect. You can't get away with not seeing some architectural diagrams. So what happens is we either get real-time transactions coming in through an API or we get them as batches. We still live very much in a batch world. The business transactions, quite often coming in hundreds of thousands of transactions in a file at once. So we get lots of peaky loads, right? We get some real-time loads where we get people at an EV charge pump, for example, that have just done a transaction and they need to get a confirmation as to what it's cost them within a few seconds. So we have to have something that's performant, but we have to have something that can cope with hundreds of thousands of transactions at a time. So we have to cope with really high speed and peaks and volume. So what happens is we come in and we go through an enrichment set of sequences, and there's a whole bunch of workers that receive the different steps for that. How do we enrich this transaction? And they reach out to other systems to look up data, and then they store the results in a database that's shared. We then go on and do the same pattern for pricing. So what are the steps that are involved in pricing that transaction? Whole bunch of pricing workers, which we'll see more about in a minute, and then they read all their data from a pricing database. And then it goes on through APIs and it's broadcast out back to other systems. Now, one of the things that I wanted to do when we designed this system is to have the principle of having business logic in one place and one place only. It's a very sensible principle to have. And when we're looking to build new services and products to go to market, what do our business people use? They use Excel because everybody uses Excel. So you then have the challenge of the business people have designed a new product in Excel, and we then have to try and translate that into rules that live in a legacy system to make sure that it gives them what they modeled in Excel. And that's really difficult, and that's very time consuming, and it's rolled out in a very piecemeal way to make sure that we've got it right. So what I wanted to make sure we could do is, because this is multi-tenanted, let's just use the production rules. So we have a scenario planner where you can create a bunch of synthetic transactions that come in a batch and are then broken up into individual transactions that are then pushed through the service. So every transaction is priced individually, but we want to keep them together if they've come in as a batch, so we know that they were a batch. So if there's a batch of synthetic transactions for a new product, we want to be able to keep them all together. So we can submit a batch and have it either go through an enrichment or the pricing, whatever makes sense, and then sent back to the calling system. So this is the multi-tenanted microservice approach that we're taking that's going to underpin how we price all of our transactions. So a bit of context, and I'm sure you can all see where NATS is going to fit. So when we have a which works out what steps to take, works out particular work, and it sends a message to each of those workers into their particular job. Similarly, pricing sequencer works out what are the There we go. And we're back. So similarly, you can see there's a very similar pattern with the sequencer for pricing. What are the steps we need to do in order to price a transaction? And the key part about this is we can add in different versions of those workers. And by just changing the sequence, we can very quickly move to the next version of a particular pricing a transaction. If it didn't work, we can fail back again by changing the sequence. And of course, the sequencer is made up of a database that stores the sequences for the different activities that we want to do. There's a manager that manages what's the order in those sequences, and it all runs on NATS. So these are the current sets of messages. I won't expect you to all remember them. I won't read them all out. But you can see we use request, reply, and broadcast messages to either say, go and do this specific activity, or here's something I've done. Pick it up if you're interested. So why NATS? So you could use any messaging technology for what we're doing here. You know, we're not talking at the moment about particularly high volumes of data. We're not talking particularly about particular performance requirements, a few seconds, any particular messaging bus service, distribution technology would be able to do what we need at the moment. But for me, this is a toe in the water of how do we put in place a messaging platform that will underpin a much bigger problem, which is not just about how do we price transactions. It's about how do we handle a distributed environment with lots of different global teams, all working to their own agendas. I don't want to put in place a lot of architecture governance and force people to use particular technologies. I want to put in place technologies and patterns that make it easy for people. And I want to have the same technology stack wherever I can. And messaging, to the point that Stuart made earlier, should just be the substrate on which everything else is built. You shouldn't need to worry about it or think about it. And our biggest problem is that we will have lots of different publishers and subscribers with different levels of quality in terms of how they behave. Some of them will be able to cope with really high volumes and peaky loads. So if you get a huge batch of transactions, of 100,000 transactions, each of those workers where they need to will scale up, do all the performance, and then scale back down again to what Annalena was saying earlier. It's a complicated environment. It's a complicated problem. And what you can't do is remove that complexity with a piece of technology. All you can do is determine where do you put the technology. Do you put it in the center? Do you put it in the messaging service that has persistent I don't with the messages. Be a global plan. It's going to come through. There's a lot of assistant subscriber that decide want to put on the messaging. I want to put all complexity in the middle. Assistants. Hey, we're back. So I boil the decision that we had down to one of two choices. Do we have a persistent messaging platform? So do we have all the complexity handled in the middleware where it queues up the messages and it makes life for the publishers very easy because they do fire and forget. It makes life for the subscribers easy because if they drop off and they come back again, they just get the messages delivered. That's going to require a much larger team to manage because you're going to have a central platform that's going to underpin all the messages that are going to flow through our systems. It's going to require more governance because we're going to have to make sure that we know what people are doing, or we just make it scale infinitely. If we have a very bad behaving subscriber on a message queue looking for a topic or a piece of data where we've got a huge amounts of volume and it goes down, you could imagine billions of messages all starting to queue up. And then when it comes back online again, will it be able to handle the load? Or do we have a non-persistent messaging platform? So the complexity of subscribers is handled by the subscriber. If it goes away and comes back, it knows what it needs to do to catch up. So if you're going to be very slow, if you're going to have to do a lot of processing when you get a message, well then let's put a queue in front of just you so that you can handle the queue. And if you can't cope with the volume there, or your message queue overflows, only you are affected. But for the rest of the subscribers, you just pick the messages up and you deal with them as you want them. So I prefer, particularly in our pricing scenario, a means of having a much more reliable messaging infrastructure. If one subscriber behaves badly, I want to boot it off the system and protect the system. I don't want everything to be affected by one particular subscriber that isn't behaving very well. And ultimately, I want this to be the pattern by which we onboard new services. So every service that comes along needs to be able to go and get history on whatever data it needs in order to perform its function. So when you start talking about storing history in a message queue, you could say, well, let's keep all the messages for a week, because if a subscriber goes down, it'll be back within a week, and therefore it can pick up the messages. Well, what if it's down for more than a week? Well, then, okay, let's make it a month. Okay, let's make it longer. Well, you can't make it longer because we can't have every message persisted for a month in case of one subscriber going away for a while. So if you're going to have a subscriber that has to go back to the source to get history, why persist it at all? Why not make the retention period a second? If you're down for more than a second and you're not there to collect the message, well, then you have to go back to the source and say, give me the data that I've missed. So I can see this being a pattern that's going to work in our environment, where we will have people writing subscriber applications that won't behave very well, that won't be able to cope with load. I don't want them to be sat on the platform and affecting everybody else. So that was for me the real driver behind NATS. The more I look into NATS, the more I see what happens, the more I look at JetStream and how it fits together with NATS. So the message queue at the bottom there will end up being JetStream. The more I'm attracted to it. And then you start adding on the security aspects as well. For me, it's a very exciting platform. And that's kind of why we chose it as a part of our pricing service, so we can get experience of it, we can get developers hands-on, and we can put something live that is resilient and reliable, performant, and our production run people can trust it because they don't really need to look after it. They literally haven't done anything they haven't need to touch it. They don't really know much about NATS. It's running and it works and they don't have any issues, and they worry about other technologies that fall over. So what's next? So the pattern of, here's a sequence of events that I want to be able to reuse and I need to do things quickly. Well, that's the same when we're looking at our card and token management. There's lots of steps in how you provision a card, how you block a card, how you order a card. We're going to use exactly the same pattern. So we'll take the same containerized instance of NATS and the sequencer with the databases, and we'll just build different workers that just do card provisioning rather than pricing transactions. We're going to roll it out across the rest of our legacy systems for pricing. And as we do that, we're moving it into the cloud. So at the moment it's on-prem. We're going to have an instance that's running in the cloud, and we're going to share the load between on-prem and in the cloud. And we're going to roll it out across in Europe and in North America. So we'll have an instance in AWS in North America, and we'll have an instance running in Europe, and we'll have an instance running in our European data center. So we'll be using that kind of cloud data center agnostic feature to make sure that we can just route the messages wherever they need to be priced. We're going to start adding in. So at the moment, we're focused on the fuels business, right? We're just pricing fuels transactions. But we're going to roll it out to look at how do we price lodging transactions and payments transactions? How do we handle FX transactions? So ultimately, all of our transactions will flow through the pricing service, and NATS will be the messaging infrastructure that then touches how do you get the data into the cloud to do analytics? How do you move it into our billing and payment services? How do we talk to Salesforce? NATS will be, if I have my way and I can convince people not to use Kafka, it will be the platform that underpins everything that we're doing going forward. And we talked about that, the multi-data deployment, right? So I was kind of smiling when Stuart was talking about that. I want to be able to look at, cloud will become a commodity. It will be who's got the cheapest compute. And so what I want to be able to do is to have an instance of our pricing platform that I can deploy through code in every environment, and then have another set of services that looks at where's the cheapest compute at the moment and what volumes have we got and where should we direct the traffic so that we can minimize our cost in terms of compute. So that's further down the line. I don't talk to people about that because it scares them. It's a bit too advanced. But what I want to do is have an architecture and a set of technologies that will enable that, that won't preclude us being really, really clever as we get down the line. And I'm looking at global domination. As I said, I want this to be this is going to be the global platform for Fleetcore. When I say global, I mean the whole of the payments industry as we go and buy them one by one. It's scary. It's scary. The number of acquisitions that we've got going at the moment is scary. And what I want to do is, the thing that our businesses ask for is, why can't we go faster? Why can't we deliver faster? So what we need is architectures that we can build on that allow us to innovate very, very quickly, that we can tweak and add different services to tweak a particular sequence of events. And we can do that using a database that's got a mapping of the sequences and something that fires NATS messages to each of the different workers that we can control. We can do it in real time. It can be real, and NATS as underpinning it is incredibly quick and incredibly reliable. And we need to be able to manage costs. Cost is a big aspect in our business. Some of our products have reasonably good margins. Some of them are very, very tight. So we need to be able to manage costs and understand where is that cost, and hence how do we optimize our cost by routing messages to the cheapest place for compute. So that's kind of our journey. We're at the start of the journey, really. We've dipped our toe into using NATS. We aren't really experienced at doing it. We've got 2 teams that are using it, that have built out our core platform for pricing transactions. It is going to grow, but it's almost about the culture change. When I talk to people about NATS in the business, nobody's heard of it. People understand RabbitMQ. They know about Kafka. So when I come along and say, I don't want to use a persistent message queue, I want to use something that isn't persistent at the heart of what we do, people don't understand what I'm talking about. So I've given versions of this talk to business people, to technology people, to developers. So I'm trying to spread the word that this is a better pattern for us going forward. NATS happens to be the best technology that fulfills the need that I think is the best approach. So as I said, we're at the very early starts of our journey. It's really exciting. I'm most pleased about the fact that it's very, very fast and it's very, very reliable. As an architect, when I want to bring in new technology, I don't want things falling over. I don't want it to be complicated. I don't want our production support people asking me questions about why did you choose it. I want them talking about the things that are going wrong. So for me, that's kind of our journey. That's why we've chosen NATS. And thank you for listening. And I'm happy to handle any questions.
So, hello, I'm Derek. I created NATS about 10 years ago, and I'm a NATS newbie. And I'll explain what I mean by that, which is I'm the most unimportant person in this room. And I'll try to explain what I mean by that as well. I'm going to go through a little bit of how NATS got created, why we started Synadia, and what I'm super excited about in the current release and what we're trying to do. Does anyone know why NATS was created? No? So in a prior life, I was at VMware and I created a platform as a service called Cloud Foundry. And I was at Google prior to that, and I had seen kind of what Google was doing. And I knew about Heroku, and I was like, wow, we need one of these for like the enterprise. And Alexis, who was still is a great friend of mine, I said, oh, I'm just going to use RabbitMQ, right, to build out Cloud Foundry. And you know, RabbitMQ is very typical of enterprise software, which is it will do everything it possibly can do to satisfy your request. And that was the last thing I needed. I did not want that at all. I wanted something that would protect itself at all costs. right? It's kind of like if someone plugs in a bad hair dryer and it blows out everybody's electricity in the whole neighborhood. That's a lot of enterprise software, and that's not what I wanted. And so on a Friday, I went home, and Monday, NATS was born. It was originally written in Ruby. It did publish and subscribe because that's kind of my heritage from the 90s and Technicron and TIBCO and Wall Street in the States. It did distributed queuing, as Adelina pointed out. It did a circuit breaker pattern. So you could say, I want to ask a question of an unknown set of subscribers and only get 1 response, 3 responses, 5 responses. And that was it. And Cloud Foundry, even to this day, is still running on that basic premise. What's interesting about what happened, though, and we need to give a big shout out to someone who's here, Brian. Brian's right there. Brian goes, hey, I think we can actually make an ecosystem out of NATS. And I remember that conversation. I said, I don't care. I'm just building it for what we're trying to do with Cloud Foundry, then Apsera. And he goes, no, I really think other people are interested in what we're doing here. And I said, don't care. I said, you do whatever you want to do. And so he says, well, I'm gonna try to kick off an ecosystem around NATS. And he came back to me a couple of weeks later and he goes, Derek, people are interested in this. This is kind of, interesting to people. And I said, why? Why is it interesting to people? And he said, it's simple, it's lightweight, and it's trying to do what it says it's going to do. It's dependable, so to speak. And so NATS was born, and NATS had an interesting ecosystem life where we were watching it, we were watching people get interested in it and people kind of saying nice things about it. And then we decided, hey, can we make this into a company? And, for everyone who's doing open source out there, you have to be very specific about a technology, even if it's kind of cool, and a company. And NATS was not a company. It was a technology. And so I went away for about 2 weeks and I said, all right, where do I think things are going? And the reason why I said that I'm the most unimportant person in this room is I've been doing this a very, very long time, getting on 40 years. I've always been ahead of the curve. I've been waiting for people to catch up until NATS. I'm trying to catch up to you. And so when I went away and I said, okay, is this a company? What are the trends that we're actually looking at that might actually be useful? The first thing I said is anything that's open source is a siloed technology, meaning I have a copy, you have a copy, everyone has a copy, can be easily stolen by a cloud provider. They can run it cheaper, they can market it better, they can provide better service for it. But I said, what if we change it into a utility? What if we literally try to connect every single digital service and device and system in the world? And of course, this has happened to me a lot, and I'm sure it's happened to you. So please don't be discouraged. People just laugh. Like, what are you talking about? You want to make it like electricity? I'm like, yeah. And I kept saying, there's these patterns that we keep seeing that aren't being replicated in the digital world, right? And it's interesting because the pandemic actually highlighted this to a degree that I've never seen, where Zoom and Microsoft Teams and pick your favorite thing became our main way of communicating. And think about Zoom, right? You're on Zoom, you don't know about the physical substrate of who you're connected to. You don't know where they are. Very rarely, at least for me, is this a one-on-one conversation. It's always a group of us. We're always kind of, intermingling back and forth. And I said, think about the digital systems and services and devices. What's a DNS name? What's the IP address? I can only talk to one person at one time. And then I got to figure out how to paper over with load balancers and all kinds of fancy stuff to do the things that we felt were normal. And so I said, I think we can make this into a company. If we actually create a utility, I think there's something there. And that's how Synadia was actually born. And we doubled down on the technology, and we did 3 major things right off the get-go. One, we created a security model that we felt was applicable to being a utility. So I picked ED25519 because it was resistant to branching and Spectre and Meltdown and all that other stuff. We created a multi-tenancy construct that is truly security isolated, so you can have what I call the Coke and Pepsi problem. And then as we launched that, I started to realize, hey, we've got all the security and it's all over TLS. This is becoming very painful for me. Me as an individual, I was like, this is painful. It takes forever to set this connection up. You know, there's nonsense coming back. There's challenges going back and forth. We have our own trust anchor. So we go through user to account to an operator, which is what's running within the server. And so on holiday break, I created leaf nodes. And I wish I had pre-thought of what everyone is using them for, but I didn't. I was just trying to amortize the cost of a TLS and the whole, you know, ED 25519 connection. And so Synadia was born. And we sat back and we watched people start to kind of gravitate towards, hey, this might be interesting. All right. And we had gone through something similar in the 90s with Fin Services where, you know, stock distribution, quote distribution, what's the price of Apple, Google, whatever it is, was starting to get to the point where in Wall Street and in, you know, Europe as well, to the point of it's not a human on the other end. It's starting to be programs. And if you're first versus last, right? Because remember, computers are like, I can make one phone call, then I hang up and I make another phone call and I hang up and I make another phone call and hang up. For humans, it's no big deal. But for programs, the person that was on the end was hugely disadvantaged to the person that was at the beginning. And so we started thinking, okay, you know, there's something here, right? And so the leaf nodes was, I was frustrated with how long it would take me to query our global system. What it's become is essentially, I think, the basis for SaaS++, a utility that you can actually extend. It's kind of like being able to buy your own cell tower and stick it in your backyard. And when you're at your house, you can use that. And when you go down the street, it just seamlessly goes into, you know, the cellular network. And so we were like, oh, this is interesting. We're kind of onto something. And we knew internally that if someone maybe would pay us, right, to exchange messages on our global network, if we could store them, they would pay us more. And I'm being very transparent, right? This was my thinking. I'm like, okay, you know, so we kind of created Stan as a one-off, just almost like I call it the spaghetti test. I do a lot of spaghetti tests. I throw spaghetti on the wall and see if it sticks. And Stan had, you know, Adelina was talking about, you know, they were using Stan early on. And I said, Stan is decent, but Stan isn't what's going to take us to the next level. I said, we really need to think really, really hard about what this looks like. And so that's how JetStream kind of came about. And JetStream has been a 2.5-year journey that's the hardest I've ever worked in my career, ever. And again, it's not because it is a hard problem. Maybe it's not hard for other people, but it's hard for me. But what's interesting is that everything we've done with both NATS core, moving it to utility and a SaaS++ with leaf nodes, and then introducing JetStream has got us to a point where everybody who's using it, everybody who wants to actually be customers or not, are moving at a rate faster than we are. And I've never experienced that before in my career, ever. I've always been waiting for people to catch up to us. You know, it's like, oh, it'll take 18 months, 24 months for people to catch up with what we're thinking. And that's when I said, you know, I'm the most least important person in the room. I'm being very sincere. Everybody in this room, everybody who's online is utilizing the technology to drive innovation in their businesses and what they're trying to do beyond what I ever thought. I wish I could claim, no, I thought about that. I knew you guys were going to do that. No, I didn't. And so we are trying desperately, and our team is so talented to keep up with everybody and what they're trying to do. And so with JetStream, we're like, okay, we need to really think hard about persistence. And so we put a couple tenants in place. It's built in, it's an opt-in, but it's inside the server. So that 15 meg binary, I think Adelina and others were talking about, it's all in there. You can create a RAF group and scale it up. But more importantly, I said, okay, if we look down towards operations and we look up towards developers, what is the most important things that they deeply care about? I'll take developers first. I said, it can't be a single message. It can't be a globally ordered set of messages, right? Kind of a la Kafka. I said, we need to create this notion of materialized views. We're not going to solve everyone's problems. But I said, if we can actually say 80% of the problems for modern distributed systems can be solved from an app developer perspective with JetStream, that could be really powerful. And so we put a key value abstraction on top. You know, and Form3, who we met with today, are so gracious because we were trying to solve problems for a lot of these KV, very massive, sparse type things. And we introduced a performance regression that, again, they were very gracious to say, hey, you screwed something up here. And I was like, oh yeah, I did. I apologize for that. What about an object store? Everyone says, well, why is the message only 1 meg? And we have so many people that keep increasing the message. You know, JetStream can actually chunk up a message and do flow control and then across the whole globe, across any cloud provider, any edge, whatever you wanted to do. And we're actually working on a couple other ones that we can talk about as well, like you know, second tier crypto networks, right? Merkle, Verkle trees, very, very quick, fast hashing algorithms that make it tamper-proof. Looking down towards operations, I said, what do we think people care deeply about? And so I looked, and at the time, again, people were like, you know, you might have bumped your head. You're not thinking clearly on this. But I said, you know, the trend right now is everything is this massive data lake, big databases, big query in Google. Everything is this big thing. But I said, I actually think the trend's going in reverse. So when Mark Andreessen said software is eating the world, I posted a little tweet that got 0 likes that said, I actually think it's going in reverse. I think we're actually going to go back to hardware. And so in the concept of JetStream, I said, I actually think we're going to go to very customized islands of data that can intelligently flow with a zero trust construct anywhere they need to be, across cloud providers, across geos, into, you know, edge, we call it intelligent edge networks. And so when we looked down, we said, okay, you know, JetStream as a core construct needs to be able to scale up and scale down, have replicas. But I said, more importantly, I think it really needs both mirroring, digital twins, and the concept of muxing and demuxing. And I'll explain what I mean by that. So muxing is you've got a bunch of endpoints. Let's say it's EV charging stations in Finland. They are collecting their own data. And there's multiple versions of massive streams that mux all of those EV charging stations into one. But more importantly, you can demux it. You can actually pull it back out and do very, very fast processing, you know, internally within a cloud provider, within an edge private data center of what you're actually trying to do. And so we kind of pushed out JetStream. And I said, look, you know, this was almost a year and a half, 2 years ago. I said, look, we've got to get this thing out there, get feedback, and then immediately, you know, light this thing up on NGS. And the team will be the first to admit that I'm overly optimistic in time. I always go, oh, that should take a week. It should take a day, you know, type stuff. And I'm always wrong. And they know it. And they point it out to me all the time. But some of the key concepts stuck. And the reason I know they stuck is because customers, by the way, key value, I said, I love Salvatore. He's a good friend of mine. I'm not replacing Redis. This is for lightweight, maybe medium weight stuff. We released it. Less than a day later, we got someone said, well, we've got 23 million keys and it's not performing the way we thought it was going to. And hence, by the way, the Form3 regression was me trying to help those guys out. So the reason I know there's something going on is because the users, you guys, everyone online is using it in ways that we never even thought about. The object store, which is just essentially intelligent flow control of chunk-based assets. So you can take a terabyte asset and it chunks it up and it's end-to-end flow controlled no matter how many nodes are in a network. We've got people using this thing to degrees that I just never imagined. So I'm very tired. Us and the team are trying extremely hard to not let the ecosystem down. But I think we're in this wave of a new way of thinking about distributed systems. It's not HTTP and REST for, you know, RPC. It's not, you know, gRPC type stuff for maybe some streaming or Kafka for streaming. People are starting to say, we need a different way. We need essentially the Zoom for all of our tech, right? we don't care where people are. We don't care how many people are on the call. We don't care if your Wi-Fi or cable modem at home is a different provider than ours. And so we've really doubled down on saying, okay, we believe we can help in a very small part to a massive transformation of the way people think about distributed systems when you say, hey, this has to be multi-geo, multi-cloud, and intelligently edge aware at the get-go. We can't, take 4 years to design this and build it out. And we've got such a tremendous amount of inbound interest. It's so deeply humbling. It really is. And again, I do want to emphasize, I'm the least important person in this room. And so we're running as hard as we possibly can because we think there's something there. And again, I've been doing this for a very, very long time. And I've seen a lot of stuff, a lot of things. And this just feels different, right? There's a massive wave of companies thinking differently about how they deliver technology to their customers, to their partners, to whatever you want it to be. And so I'm so glad you're here. I'm glad that I was able to be here and Brian asked me to tag along. Like I said, we owe Brian a huge debt of gratitude because I said, nobody cares about NATS. We care about it, but no one else is going to care about it. He goes, no, there's something there. And I think we're on the cusp as an ecosystem, not us, not Synadia, not NATS, but as a technology ecosystem of really reimagining how technology is delivered. And if we can play a teeny small part of it, that's awesome for me. I love that. So I wanted to keep it short. I will ask or answer any question you have. I might not know all the answers, but I probably know most of them. So please fire away. Hit me with anything you have. If you can make me squirm, that's the best. I like when people try to make me squirm.
This is, oh, sorry. I'm not. This is amazing. I love the journey that NATS has been on, like from core NATS, like fire and forget, as Adelina put it, which is great, through Stan and JetStream and the persistence and the delivery guarantees with key value store on top now, because you can do that because you've got persistence. And all of a sudden, NATS is really suitable for a control plane as well as a data plane, right? So Adelina and David were talking about NATS in the context of a data plane. I was thinking about it more in my talk as a control plane. And I saw that there's a pull request on K3S to, or on Kine actually. And I love that Kine is one of those reflexive anagrams. So Kine is not XCD, and this is great, right? And this is a pull request to substitute etcd for effectively JetStream, right? Which would enable, if I'm not wrong, distributed Kubernetes clusters, right? So right now, Kubernetes has to really be in one city, maybe multiple availability zones. But now this enables Kubernetes to span the globe, right? Can you talk a little bit more about that? Thanks.
Yeah, so that's a great question. And so what we did was Darren Shepard, who if folks don't know, was part of Rancher. And he created a abstraction interface to etcd, which is the state management machine for Kubernetes. And he plumbed it into Kine and then /K3S, which is a more lightweight version. And a lot of what Synadia's business is looking at is edge, intelligent edge, IoT, and Industry 4.0 type stuff, where you might not want to run full-blown Kubernetes. And so I reached out to Darren and I said, hey, I think we might have something here. And Darren in Darren fashion said, I don't know. And I said, look, the way we've built NATS, we can plug it in with a KV materialized view of JetStream inside of K3S. I said, you now have the state machine in K3S is NATS, but NATS is securely multi-tenant. So all of the applications can use NATS and JetStream and KB and Object Store as well. But I said, what becomes really, really important in my opinion is I will show you a demo where we can connect 500,000 connections to a single NAT server. I said, how many K3Ss can you guys manage? And he was like, ooh, okay, let's talk. And so actually, I think it landed. It's not only a pull request, I think it actually landed. It actually is real now. And this notion of fleet management, which sounds like, oh, it's got to be trains, planes, automobiles type stuff, is actually a very, very common pattern for almost anything people are doing today with the edge. It's, I need to be able to query it. I need to be able to observe it. I need to be able to update it. That's essentially what I consider fleet management. And even for us, Synadia, we've gotten customers that have come to us and said, we're in this business and we've got these things and we've got 50,000 of them, 100,000 of them, 1 million of them. How are you going to manage that? And so that's an extremely exciting place for us. Now, I will say this, and I might get in a little bit of trouble, but that's okay. You know, I've been doing this a long time, which means I've seen trends. So things that I would have guessed weren't going to happen, and they do happen. So I got the scars on my back. And what happens is that when the unit of deployment changes, the incumbent technology never makes the jump, ever. So what I mean is, as soon as the deployment unit changes from a container to, let's say, WASM, whatever the incumbent technology is, it never makes the jump. It just doesn't. At least in my history, you know, I've never seen it make the jump. And so it's interesting for me to see what's about to happen. And I do believe, you know, I know you guys were doing a lot of work with Cosmonic and Kevin and Liam, and Kevin was pinging me earlier today. I have a huge belief that there's something about WASM. It's really going to be something interesting. What's interesting about NATS and JetStream is we are payload agnostic, which means we don't care what you're sending. So you can be sending a request, a reply, data, an event stream, a digitally signed WASM module. That's an over-the-air update to 150,000 edge deployments that executes, you know, like the designed here, you know, executed here type of stuff. And so the K3S stuff is really interesting to us. We have a lot of interesting folks that we've been working with and partnering with around smart infrastructure, smart energy systems, you know, lots of, you know, energy deployments, whether it's EV charging stations in Finland, you know, telephone poles in, you know, the south of America. And this pattern really resonates with them. I'll tell you some of the, it's going to not be a secret after we talk about it, but some of the things that we snuck into 2.8, I think are really going to resonate with people. And they're still beta a little bit, but we're trying to make them as real as possible. But the notion of instantly being able to scale up a stream from 1 to 3, back down to 1 to 5, whatever, is live. It's in 2.8. It's on NGS. And NGS is live now with self-service JetStream. You can actually go on the website and sign up today. What we also did was, when you create a mirror or a digital twin or a source mux, demux, whatever, you can chain those infinitely, as many times as you want. And what's interesting is people are starting to realize that given a certain context within a message, within an event, depending on who's looking at the event, the temporal semantics and the business semantics change. What I mean by that is if I'm trying to do a business transaction, a certain thing might not be viable after 2 minutes. But for audit or governance or anomaly detection, we might need to hold on to it. One of our customers holds on to things 20 years, you know, and in terms of being able to go back and see everything that's going on. And so the ability to chain these things together to you know, move things around. We also launched the ability to move streams on the fly, like an airline in flight. You can change the engine out of it. So I've been giving private demos to people. Sometimes, most of the time they work, sometimes they don't, but I think we're right there, where we'll move cloud providers, move geos, you know, with mirrors attached, and just move these things around. The other thing that we just launched, again, that we're being quiet about, but again, I am deeply humbled to be here, and I want you guys to have something for it. Is, let's say I ask a stream about its information. I go, hey, tell me about yourself. And I go to you. What the system is now doing, and it's live in NGS and it's in 2.8, is it will actually report back all of the alternates, all of the digital twins that have been assigned to it in priority order based on my reference frame of when I asked the question, where I was in the world, what cloud provider I attached to. And so even the origin is in that list. So it might be that you're the closest person to me. And so you'll be number one in the list. But if there's 3 replicas, let's say you're closer to me, you'll be number one on the alternate list. And so what you're starting to see is us thinking about, okay, where do we think this thing is really going? And again, I think it's going to be the massive data lakes and the massive, cloud computing to do machine learning and AI. I don't think that's going to change, but I think the way people consume and interface with technology is going to be very purposely built, smaller subsets of information that can intelligently flow wherever they need to be. And we're making a bet on that. And so I said, well, what would make a lot of sense there to be able to do? And so if we say the system is intelligently aware of all of the replicas, how they're placed in the world, and the reference frame is me asking the question, and returns a list that's specific to me saying, no, you need to talk to Stu. He's the closest to you. He's the best, fit for what you're trying to do. We're trying to, again, keep up with the ecosystem and try to think about, where's this all going to be in 5 years? And Stu and I were talking about this earlier. The world is changing so fast. I mean, we have multiple compounding exponential technologies that are at play right now. So the world in 5 years is going to look very, very different. And all I can promise you is that whatever I'm guessing is going to be wrong. But I'm trying as hard as I can to guess, where is the puck going? What is it going to look like? And can NATS play a small role in that? So again, deeply humbled. I'm so in awe of what you guys are doing with the technology, and we're trying our best to keep up. And we will keep trying our best. And I'm happy to answer any single question you have, really anything. And as the team always like to say, they go, make him squirm, ask him something that really, gets him to squirm a little bit. So thank you again, by the way. And thank all the speakers. It was awesome. Oh, do you want me to read them? Does NATS have ACLS? Yes. So NATS has 2 security contexts, main contexts. One is an account. Think of it like a DMZ or a multi-tenant isolation. I call it the Coke and Pepsi problem for, it's global, but, those in the US are what we call the FedEx and UPS problem, meaning by default within the account, you can see everything that's going on. And by default, you cannot see anything that's going on in another account. And the only way that you can share constructs between 2 accounts is kind of like Facebook. We both have to agree that we want to exchange information. I think an earlier question to David was subject hierarchy. And by the way, early in the 90s with, this is dated, but technology I designed in the 90s, TIBCO's Rendezvous and TIBCO's EMS, we would have 2-week-long design session with customers on their subject hierarchy. And it always bothered me, but I didn't have an answer for it. And so with accounts, what I said was, hey, if we want to share something between accounts, and let's say you export something, you export a service, meaning I can send something to a subject that you're listening on and you'll give me an answer, like what's 2 + 2, and you'll send back 4. The really interesting part at the very end of when we were designing was I said, well, wait a minute, if it's my account, I should be able to put any subject that I want, not what you think it should be, but I can say, I just want to send a foo, and it goes to your cool service.add.to number, whatever that is. And so when we did that, we started seeing customers immediately go, wow, we can radically simplify our subject space because we'll just keep putting accounts around almost every microservice, every stream that we want to publish out. And so that was kind of my answer for that. So account is securely isolated. You have to agree to exchange information. Within an account, by default, everybody can see everything. Any user within an account can see everything, but you can then start locking that down, right? And you can do allow lists, which like if I say, oh, Derek's only allowed to see foo, that's the only thing I can see. Or deny, I can see everything except bar. And then we also have a notion within accounts for the control list of saying allow responses. And what that means is, as a microservice, I can come up and go, I can listen to the request subject, but my only publish permission is to reply to any subject that was validly given to me. It has to have been given to me. And even on the reply notion, is it a singleton response, a stream response, or a chunk response? And so that's kind of the ACLS thing. Did I understand correctly that you created leaf nodes to get rid of certificate management, or is it just having no idea what leaf node is? No, what I was trying to get rid of was the amortized cost of creating TLS and doing a nonce challenge, meaning I would do the whole TLS thing, then the server would send back an info packet. If you've ever telnetted to one of our servers, you'll see an info packet saying what version, all the things that it has. And if it's secure, it'll send you back a nonce. And what you need to do is you need to take that nonce and sign it with your private key as a user and send it back. And that's a lot of stuff. It's a lot of security, which everyone likes. I was getting very frustrated by every command I was trying to send to NGS would take half a second to respond. And so I wish I had thought about SAS++, but I honestly didn't. It was more about, I want to amortize that cost and just have almost a persistent connection that's always running. That's what leaf nodes were.
Hi there, I've got a question, if I may.
Yes.
Thank you for the speakers today. They were really, really good. And I am a fan of NATS. I work with companies that may be in varying levels of digital transformation and quite often tend to implement Kafka as a solution without thinking of anything else beforehand. And as much as I try, may not be able to convince them. So my question to you is, what is in your experience, the most compelling argument to use NATS over Kafka?
So that's a great question. The question is, what is the reason to potentially consider NATS over Kafka? I'm going to start with why you shouldn't use NATS over Kafka, right? Kafka has a massive ecosystem. If you are all JVM shop and you've got Spark and Fink and all these types of things, right? Kafka is probably the right answer for you. Where we started seeing customers come to us is they said, look, anything that's centralized for us is an anti-pattern of what we think future systems are going to look like. If I have to trombone to any central location and come back, whether it's a cell tower, a cellular operator, Kafka, a database, it doesn't matter. I think the days of those patterns are very limited. And so we had a lot of customers coming to us and going, look, we're missing out on opportunities because we've got a trombone all the way to Kafka and come all the way back. And we've already missed the opportunity for in-game economies, Industry 4.0 events, things like that. Can you help us out? Because if we try to set up 5 or 6 remote Kafka clusters that do store and forward and mirror maker and all this other stuff, the cost of management and the amount of people we have to hire to do it just doesn't make a lot of sense. And so we said, absolutely. So we created a bidirectional bridge that's open source. And we said, we can do lightweight JetStream on the edge, and then we can go back and forth. And so you can actually store, collect, analyze, and respond to data on the edge and still have the main Kafka cluster for analytics, massive processing and stuff. What we found is that similar to the KV functionality we put in JetStream, which I purposely said, I'm not trying to replace Redis. I don't want to do that. We started to get customers that said, we love the features of Redis and you're really simple, but the ability to create digital twins and mirrors and move these things around and overlay it on an arbitrarily complex topology that goes between clouds and geos and intelligent edge, extensions is more important to us than that. And so what us personally have started to see is people go, that's more important to us than the other stuff. And so even though I've told them, nope, we'll be at the edge, don't replace the core Kafka clusters, that's not what we want to do yet. People don't listen to me. And so we've got a lot of people say, no, we like this. And what they're going to do, and this is good, is they're going to push us, right, to be better. And we're going to try to, as best we can, rise to the challenge. But if you're looking for something that's, and by the way, JetStream is young compared to Kafka. NATS is older than Kafka, the core. But JetStream is still young. But if you look at like our 2.8 release notes, which just came out the other day, and you kind of get a sense of everything that was done. If you frame it within the time frame, that was 5 weeks. That was it. So everything in that 2.8 release notes is 5 weeks. And I've told the team, I said, look, our job now is to move as fast as our user and customers are moving, and they're moving faster than us. And that's the best problem to have in the world. It's scary, but it's the best problem to have in the world. But I said, we have to accelerate as fast as we possibly can. And so that's what we're going to do. We're going to keep doing it, because everything I've told people not to do, they do the opposite. You know, KV, lightweight. Hey, we've got 26 million keys. We had one the other day was 200 million keys, you know, and they're like, hey, we're looking at this problem and it looks kind of funny to us. And I'm like, how many keys do you have? 200 million. It's a 26 gigabyte JetStream stream. And I was like, okay, all right, okay. You know, we're going to double down and do our best. And what we're trying to do as hard as we possibly can is enable the ecosystem. Really, I mean, that's all we're trying to do right now. And so when all these customers like Form3 and, you know, all the people we've been meeting in London are saying, hey, we want to, you know, bet our business, a small part, but I mean, we're kind of like plumbing, which you usually don't care about unless it fails. Then you care deeply about, you know, your plumbing failing. You know, can you help us? You know, can you step up? And what's good about the team around NATS is we cut our teeth in Wall Street, and I had to be on planes, you know, all the time, flying in and getting yelled at and stuff like that. Meaning we understand the importance of what we're trying to do and how important it is to the ecosystem, our users and customers. And so we're going to do our absolute best. And again, I think as a group, we're on a cusp of just a different way of looking at systems. I've seen so many customers who used to be, well, it's HTTPRS and gRPC and Kafka. And they have like a light bulb moment where they go, we need to think differently about how things are connected and how multi-cloud plays effect, multi-geo plays effect, and how we extend out to partners and consumers. And, you know, I mean, the NAT server, I think Stu and Adeline were mentioning, is 15 meg, and that's bigger than I ever wanted it to be. But it still runs really well on a Raspberry Pi 02. You know, it can do 100-some thousand messages a second on one of those things. Now, you might not want to do that, but when we look at, hey, can we run this in top of rack switches? Can we run it in cable modems? Can we run it on wind farms? Can we run it wherever it needs to be to give the customer the best experience? We want to be able to say yes more than no. So Kafka's ecosystem is strong. The connectors on a lot of the data analytics, the you know, type stuff are very, very good. I do believe we're in a massive transition from massive data lakes to isolated, intelligently flowed subsets of data. I also think we're in a massive transition to everything is going to be transformed with machine learning. There's not going to be a Spark and a Fink and stuff within a couple of years. It's going to be, what is the best inference engine to do anomaly detection on Industry 4.0 turbines for aerospace or whatever that is. And we want to be kind of the delivery mechanism to say, we can collect the data, we can federate learning east-west, north-south. We do the training, and then you digitally sign the inference engine and we send it back over. The other thing that a couple of people have come to me and they know what's going on. They looked at me and they go, hey, wait a minute. So JetStream can do a globally ordered set of messages globally. I'm like, yep. And they go, and you talk about intelligent data flow. I'm like, yep. And they go, if I can decompose any external data store as a sequence of messages, you can then take intelligent data flow with JetStream to data that you don't own. A SQLite database, Postgres database, Cassandra database. And I'm like, yep. And we knew that, right? But we're pedaling as fast as we can. We're just not there. But we want to actually enable intelligent data flow and in a zero trust construct to data that we don't have. Right now, we have so many customers that are not in pain, but are looking for an aspirin, if that makes sense. And so they're willing to put in the time to learn NATS. And we try to make NATS clients very easy, right? But with JetStream and all, they're getting complex, right? There is a cost to converting or building new apps in that. But the team is already hard at work thinking about how do we actually introduce NATS and things like NGS and JetStream in a construct where you don't have to change anything about your application. that's talking to a Redis key value store or a database, right? And now all of a sudden you're intelligently aware of multi-cloud and multi-geo and things like that. And so that's coming very, very quickly. You know, like I said, we're pedaling as fast as we can. We're like a duck on the pond. We don't look like we're moving very fast, but the team is trying really, really hard.
Thanks.
Let's see. Any plans on NATS cookbooks to help new folks be able to quickly grok and play with the different strategies? See someone constrained, Node.js, Dino, but it looks like the Java client is more mature. So that's a great question, by the way. And I think we have 43 different client language implementations now. We've been really focused heads down on the core and JetStream and, you know, clusters and super clusters and leaf node, you know, extensions type stuff. We're about to switch back to really doubling down as hard as we possibly can on the clients. We have an amazing team member, Tomasz, who's out of Poland. And while he's not trying to help Ukrainian refugees, he's cranking so hard on the async Rust client, you know, that's Tokyo aware. But we're doubling down on the clients really hard. The other thing is that we've realized there's a massive shift in the ecosystem, not necessarily about us, it's just in general, which is don't necessarily just show me the docs. Show me a tutorial. Show me a GitHub repo that I can copy and change to my liking. And so we're really starting to double down on shorter content, tutorials, short YouTube videos. And so I think you're going to see a lot of changes there. And we can always get better, but we're trying really, really hard on that. Yeah, so the practical experiments. One of the things that we did, we had an ecosystem member create a NATS CLI, which has become the focal point for everything that I do. So when I demo, I don't write applications. I just use the NATS CLI to do almost everything. So we encourage everyone to look at that. What is your prediction thoughts regarding discoverability of topic services? And how can it be solved for NATS? That's a great question. NATS right now, remember we talked about the security constructs of within an account and then multi-account and how you would actually go back and forth between accounts. The way you go back and forth between accounts is you will export either a stream or a service. A service is I have a listening endpoint. You can ask me a question. I'll give you an answer. And a stream is I'm publishing something. My temperature is 98.6, you know, Fahrenheit. I'm a Yank, sorry. Within those exports, you can actually attach URLs for like open APIs. So you can start to think about, oh, I can kind of discover what a request looks like, what a response looks like. We've got a lot of work to do there, but the original goal of NGS was to provide a marketplace for people to easily write streams and services and have us do all the heavy lifting for them. They say, hey, we want you to run 1,000 of these worldwide, chase the demand wherever it is. And we can do that today. The system is observable enough that we understand where all the demand's coming, where all the latencies are. And so we can respond to that. We haven't done it yet, but we're about to.